Have you ever really thought about what happens in that split second after a toll booth camera flashes? It's not just a picture, you know? It's actually the very beginning of a high-stakes journey through a hidden digital world. And today, we're going to follow that journey, step by step.
You know the feeling, right? You see that bright flash in your rearview mirror, you just keep on driving, and then, like magic, a perfectly accurate bill shows up a few weeks later. It seems so simple, almost automatic, but the process of turning that one photo into a bill is honestly a marvel of modern tech. So, let's pull back the curtain.
So that flash, it's like the starting gun for this whole complex process where speed and accuracy are literally everything. This isn't just about taking a quick photo, it's about launching a tiny piece of data on a mission with a very, very tight deadline.
And just try to wrap your head around the sheer scale of this. We're talking about millions of images every single day, coming from thousands of different locations. And each one has to be processed with near-perfect accuracy. This isn't just a big data problem, it's a huge precision problem.
Okay, to really understand how this all works, let's follow just one of those images. We're going to treat it like our main character, starting its big adventure the exact moment it's captured by that camera.
All right, here is the first big aha moment. The system doesn't see a photo, it sees a request. That one word changes everything. It reframes that picture as a task that needs to be done, a puzzle that has to be solved. And the mission? To identify the exact license plate, the correct state or province, and all the other little details needed to get it right.
And this mission, right from the start, is packed with real-world obstacles. We're talking about images streaked with rain, sun glare that totally blows out the plate, cars whizzing by in a blur, and of course, plates that are just covered in mud or peeling from age. So that simple photo, it's suddenly a really complex puzzle.
So how on earth does the system solve this puzzle millions of times a day? Well, to find out, we need to go inside the processing engine itself, where our little request is about to run a digital gauntlet.
Now, this diagram shows the entire ecosystem. Don't worry about trying to read every single box here. The key takeaway is the flow. See how data comes in, moves through this whole web of databases and services, and gets handled by both automated software and actual human beings? It's basically a digital factory, built for one thing: getting fast, accurate IDs.
With all these different paths a request could possibly take, how does it know where to go? Well, that's the job of something called the workflow service. The best way to think of it is as the system's brain. It takes one look at each new request, checks its quality, and based on a set of pre-programmed rules, decides its fate. Can a machine handle this one, or does it need a human touch? The brain charts the entire course from start to finish.
You know, we can actually break that whole complex journey down into these 4 basic steps. First, the image gets submitted. Second, it officially becomes a request, and the brain gives it its first assignment. Third, it goes through that review gauntlet, bouncing between machine and human until it's solved. And finally, the verified correct answer is sent back out. Simple on the surface, but incredibly sophisticated underneath. And when you've got hundreds of human reviewers all working at the same time, speed is absolutely everything. You can't have them sitting there waiting for the next image to load. That's where the task cache comes in. Think of it like a super fast waiting room. It holds all the puzzles that are ready for a human, so the absolute instant a reviewer is free, a new image is presented. No lag, no waiting. Just boom, next one.
So we've mentioned both the automated systems and the human reviewers, but the real magic of this entire operation isn't in one or the other. It's how they're combined into this incredibly powerful, seamless team. In this slide really shows that perfect partnership. The machine, using what's called optical character recognition, is built for pure speed. It can just blaze through thousands of perfectly clear, easy images, getting the obvious ones right in a split second. But the human reviewer brings something the machine just doesn't have: nuance, intuition. They can figure out a blurry character, understand the context of a damaged plate, and see right through glare. The system just brilliantly uses the strengths of both.
And this is their command center, what we're calling the reviewer's cockpit. Right in the middle, you have the image itself. Over to the left, you can see what the automated system or maybe another reviewer guessed. On the right, a set of tools to make the image clearer, and at the bottom, that's where they input the correct data. Every single piece of this is designed for maximum speed and accuracy.
This quote, straight from the system's design document, really says it all. Speed of presentation to reviewers is a guiding principle of VIP. In this world, every single millisecond you can save, when multiplied by millions of transactions, adds up to a massively more efficient system.
And this right here is exactly why those human reviewers are so crucial. On the left, you've got an image that's pretty much impossible for a machine to read.
It's dark, there's a ton of glare. But with the tools they have, a human can turn it into the crystal clear, obvious image you see on the right. That's a perfect example of a problem that would completely stump an automated system.
And these are the simple but incredibly powerful tools they use to work that magic. They can boost the brightness on a shot taken at night, crank up the contrast so the letters just pop, and even invert the colors, which, surprisingly, can make faded text perfectly readable. It's like they're doing digital archaeology, but in real time.
Okay, so we've got a system that's incredibly fast and super smart, but with millions of transactions flying through every day, how do you guarantee it stays accurate? Well, that takes another final layer of intelligence, constant quality control.
Because the goal here isn't 90% or even 95% accuracy. The system is engineered from the ground up to achieve an accuracy rate of over 99%. And let me tell you, getting there is one thing, but staying there requires a constant process of checking and rechecking. And the main tool they use for this is the audit. The easiest way to think of it is as a review of the review. Supervisors can just pull a random sample of one person's work to check their performance, or they can audit the final results to make sure the whole machine-human team is getting it right. It's the ultimate system of checks and balances.
And these audits are so important, and not just for catching mistakes. The real power is in the data they generate. That data gets fed back into the system to help train both the human reviewers and the automated software, which makes the whole process smarter and more efficient over time. It's all about continuous improvement.
And so, from that single flash on the highway, our little request has completed its amazing journey. It was challenged by bad weather and high speeds, analyzed by a machine, scrutinized by a human expert, and then verified for quality. All of this happens invisibly in the background, just to make sure our roads and transportation networks work.
And that kind of brings us to a final, bigger question. This powerful combo of machine speed and human intuition isn't just for toll roads. It really makes you wonder, what other parts of our world, from the packages that show up at our door to maybe even medical diagnoses, are being powered by these hidden human-machine teams, all working silently to make our complex world run?